Well, hello, boys and girls. How are you today? Yes, it is Mr. Brisson here to do another science lesson, and we have no light. And our lesson today is about light. No light. Light. No light. Light. You might be thinking that it is quite a jump to go from water waves to sound waves to light. Why are we doing light together with waves? Well, I'm sure you remember from last week that light travels in waves. And that's why that lesson goes together with waves. Light travels in waves, but very different. We have to spend some time talking about the differences today between a ocean wave, a sound wave, and a light wave. Light completely different. So let's look at our learning target. So the learning target is I can explain what light is, how it travels, and what happens when an object is on the way of a light wave. Okay? So I can explain what light is, how it travels, and what happens when an object is on the way of a light wave. Let's do a little review and talk about ocean waves. So you remember that what was traveling? Energy or water? That's right. The water was not traveling. The energy was traveling through the water, making those waves. Remember the particles that were pushing down and then they would go up and down and up. And remember sound waves? What does sound needs to be able to travel from one place to another? That's right. Either liquid or a solid or a gas. Why don't we have sound in space? You remember? What's the reason for that? Well, because there is no air in space. So sound needs either a liquid, a solid, or a gas to travel. So no sound in space. Light is different. Light is different. Well, first of all, let's talk about sources of light. The main source of light that we have on our planet is the sun. But we also have other sources, right? Like lightning or a fire or a candle or a light bulb, a lamp, right? We have many other sources of light. Let me ask you something. Can we see light from the sun? Can you see the sun? Yes, we can see the sun. So the sun is out there in space, okay? Does light need a gas to travel through? Think about that. Pause the video and think. Does light need something, a medium, to travel through? Think about it. And why would you say yes and why would you say no? So if you thought about it, you realize that actually light does not need anything to travel through. It does not need gas, nor a liquid, nor a solid, because the sun is in outer space and we can see the light right here. So the light from the sun traveled to our planet through space. And in science, we say that it can travel through a vacuum, not the vacuum that you use to clean the house, but a vacuum is something that has no particles inside, no matter inside, no gas, no liquid, no solid. Okay? So light can travel like that, but it travels in waves. So let's explore that a little bit more. What made the waves for sound? It was the disturbance, remember? The disturbance, and then the sound, the disturbance pushed the different particles in the air creating the waves. But if light doesn't need anything to travel, are there any particles to push? Are there any air particles to push, or any solid particles to push, or any liquid particles to push? No, there isn't. So actually, light travels like the actual light, okay, is an energy that travels in waves. And there has been some debate. Is light energy or is light an actual matter? But the conclusion so far is that light actually is energy. And that energy travels in waves. And it doesn't need anything to travel through. Okay? It doesn't need anything to travel through. It can travel in a vacuum. Not the cleaning vacuum, but in a place where there is nothing. Okay? Now, I want you to answer this question in your notebooks, okay? Answer this question. What is the main difference between the way sound energy and light energy travel? Okay, so pause the lesson and answer this question in your notebooks. So the main difference, of course, is that sound needs a medium to travel through, like a liquid, a solid, or a gas. And light does not need anything to travel through. It can travel in a vacuum. Not a vacuum cleaner, a vacuum. Let's look at our learning target real quickly so I can explain what light is, how it travels, and what happens when an object is on the way of a light wave. All right, so we are getting there, but let's look at a definition of light. So light, according to the dictionary, is a form of energy which our sense of sight, our eyes, can detect, can see. It is made of electromagnetic radiation and travels in waves in a straight path. Okay? So that's what light is. So it's energy. Our eyes can see it, can detect it, and it travels in waves in a straight path. So we know that it travels in waves, and now I introduce something new. It travels in a straight path. In a straight path. So I want us to look at this video, okay, that has a demonstration to show us how this thing about light traveling in a straight path works. Okay, so let's open this video. So the video is light traveling demonstration. Click on that, okay? And watch. And also do and answer the question that the guy asks in the video. Pause the lesson and watch the video. So did you guess? Did you guess where the light was going to go? First, second, or third circle? Did you guess right? Well, if you didn't, now you understand why it was supposed to be that specific circle. Because it travels in a straight light. In waves, but in a straight line. Now, do you remember a while back when we were talking about night and day and shadows? Do you remember how a shadow is formed? You remember that? Remember how a shadow is formed? That's right, when an opaque object blocked the light. Because light travels in a straight line, it couldn't just go around the object, because that would not be a straight line. It couldn't just keep going straight and then go around the object and then keep going. No, the object blocks it because light only travels in waves in a straight line. So that's why shadows were formed. Because the object blocked the light from continuing in that straight line. We are not going to answer these questions today, but I'm going to ask them to you, okay? What happens when light encounters a glass or water? Think about that. Start thinking for the next lesson. What happens when light encounters a mirror? Have you thought about that? Well, I just want to start getting your mind to start thinking about that, because that's going to be our next lesson, okay? But today, I want you to go to your notebooks now, and I want you to take about 5 or 6 minutes. And I want you to explain, okay? See if you got the learning target. I want you to explain how light travels, okay? How light travels. And then I want you to talk about or write about what happens when an object, opaque object, it's in the way of the light wave, okay? So number 1, how does light travel? Number 2, what happens when the object is on the way of the light wave, okay? And now let's take some time to share what you wrote. So maybe 3 or 4 students can share with the class what they wrote down, okay? Let's do that. Let's pause the lesson and share with the class. Well, thank you, boys and girls, for your hard work today. Now you know how light travels, what light is, what happens when light encounters an object. And next time, we are going to talk about, or we're going to discuss, okay, how the appearance of objects change depending on the light source. And also how light appears, right? Like we didn't talk about the glass, the light going through the glass and light encountering a mirror. So we're going to be talking about those things, okay? And is there a way to bend light? Is there a way to bend light? We said in this lesson that light travels in a straight path and that it couldn't go around the object, but have we found a way to bend light? Well, we're going to talk about that in next lesson. Thank you so much. Have a great day, and I will see you next time. Remember that science is everywhere. Bye-bye.